Jonathan, I'm really upset. You let us all down. Now we have 4 people again, and then Friday, we don't meet tomorrow, and Brendan's already announced he's not going to be here Friday, so.
It's a lost week.
Yeah, really. All right.
Huh?
Today, Jonathan, I already announced we're starting 9.2 on series, so get ready to take notes. Brendan, could you shine a light? This was a question that everyone had from 9.1b, and it was finding out whether this converged or diverged. It was a sequence. If you watch the yellow, you'll see that it just ended up back to where we started, so it was sort of a dead end. So this is one of those ones where you got to pull out some algebra and try to get more denominators going. So I went over here into the orange and went down, and then over here and finished here. So it's sort of out of sequence. And the answer is number 2. The answer, when the final limit was taken, we did get a 2 there. So that might help you. I can go over it with you if you can't follow the work. Took us a while to wander through the desert here, but we're in the promised land of 2. Series 9.2. All right, back over here. Oops, these are the trashed ones. All right, on the series, first of all, let's go back to sequence land just to say goodbye. Actually, we're going to say hello because who's here to stay? Some guests don't like to leave. So when we're talking about a sequence, remember how we put it in the braces and we identified it in this way? There are commas between each entry and they march off infinitely. At least the ones that we've been looking at do. Well, the only difference between the sequence and the series is I'm going to take out these little commas, and what am I going to put in there? Do you recall from your math past? You've had this
A4,
at least.
A5.
Yeah, there's going to be A4.
Is it semicolons?
No.
Addition signs.
Right, thank you,
Darn
Aaron. Right, it's plus.
I was saying,
So,
this ring is like vampire time.
when we talk about a series, we talk about not just individual terms separated by commas, but it's a long addition problem,
splice.
an infinitely long addition problem. But we can deal with infinity with ease by now. So, I am going to show you whether or not a series converges or diverges. A series converges. Write this statement. A series converges if the partial sums converge. So, I have to tell you what a partial sum is, but go ahead and write the statement. A series converges. It will converge and diverge just like our sequences did, but it depends on whether or not the partial sum of the series converges or diverges. So, what is the partial sum? In theory, if I go back to this one, S sub 1, that means the first partial sum is A sub 1. S sub 2 is A sub 1 plus A sub 2. S sub 3 is A sub 1 plus A sub 2 plus A sub 3, and so on. So actually, from this series, we're going to create a sequence. And if that sequence converges, then we know that the series does, and we actually know the sum of the infinite series, which is always amazing to me, that we can add up an infinite number of terms and come up with a number. But that's the long and short of it. So that's the theory. Now let me show you a problem so you can understand more fully what I'm talking about. Examples. Example number 1. Well, I'll write this, when I erase the board, write down this series, a couple of entries from this series. It's 1 over 2 to the n. So in the denominator, it's 2 raised to the n. 1 over 2 to the n is the series. And I want you to generate a couple terms. while I get some board space going.
I feel like we do this one a lot.
What was that?
I feel like we talk about this one a lot.
Yeah. It's a,
Oh
it's a
wait, I
nice,
understand how you do this.
it's a nice example. All right, so the example that we're looking at is 1 over 2 to the n. I'm going to use summation notation to indicate that it's a series because we're comfortable with that. So I'm going to put in front of it the summation sign, the Greek what, sigma, is that what that is? N goes from 1 to infinity, that's the domain, and that tells you all of the values you're allowed to put in for the unknown variable. So, were you generating some, Brendan? What'd you get?
1/2, 1/4.
All right, and this time, between them, make sure you're putting a plus sign,
Oh.
and if you're not, I'll never know because you're gonna go stick it in there. All right, so that is our first example of a series, and our question is, does it converge? And we said over here, it converges if the partial sums converge. So what are the partial sums? According to my list, the first, and so I'm going to call it, here's this, remember this is my notation for sequence. So I'm going to make a sequence out of these partial sums. So the first one is a sub 1 is 1/2. That's the first one. Now I have a comma because I am developing a sequence from these partial sums. So the first one is 1/2. The second one is whatever is 1/2 plus 1/4 because the second partial sum is the first two terms added together. 1/2 plus 1/4 is 3/4. The third partial sum in my sequence is the first three added together, so that's going to be 3/4 plus 1/8. So what's that, 7/8? Okay. And then the third, or that's the third, the fourth, I'm going to add 1/16 to that, so that's 15/16. So you can see here that we're already developing a pattern of sorts here. So can you see, this is why I asked you to practice coming up with the generators.
60.
I need to know the general term now for this. Remember, we're putting in a 1 in here, a 2 in here, a 3 in here, and a 4 in here. So what are we generating? What could generate this sequence? See if you can come up with it. You're coming up with a general term here with n's that will create this march. So you look at the numerator. Usually we do the numerators separate from the denominators. Probably
I think I know the top.
what's the
Is
top?
it 2n plus 1?
2 times n plus 1. Let's see if that works.
Oh no, that's not going to work for the first one.
Oh,
It works for the
that
ones
was,
after
that
that.
was a quick
I was
no-no.
thinking n squared minus 1, but it doesn't work for the 3, but it works for all the other ones.
Oh, I hate when that happens. All right, let's go down the denominators. Can you see that one? It's probably a little clearer than the top.
No,
The
n
bottom.
squared.
1 became a 2, 2 became a 4, 3 became an 8, 4 became a 16.
Is it squared?
Pardon?
Oh no, they're not squared.
Where'd you get 2 squared?
It's n
Four.
squared. The
What about
second
the
term.
3
No,
one?
no, I'm saying it doesn't work for the third
You
part.
see, 8 gives it away for me.
Oh, is it 2
Third
raised to
term
the
and
n?
an
minus
8,
one is
what is
It's
that?
2.
What's that connection?
2 raised to the n.
Very good. Yes, 2 raised to the n. Let's check her out. 1, 2
Yes,
raised to the
and-
1, 2. 2 raised to the 2, 3 raised to the 2, 4 raised to the 2. Very good. That's awesome. I'm sorry, I didn't do that right. 2 raised to the 1, 2 raised to the 2, 2 raised to the 3, 2 raised to the 4, and so on. Now you should be able to get the top, because what's the difference between the top
2n
and the
minus
top?
1.
Very good.
Oh, I was almost there.
Oh.
2
What a
to the
shame.
n minus 1, which is what you meant. All
Yeah,
right,
that's what I meant.
so
Yeah, good try.
once you develop the series and the sequence of partial sums, you come up with a generator. Now you got to find out if that converges or not. So pull out your limit and find out.
This is the wrong problem. Limit as n approaches infinity. is infinity.
Once
over
again, what
infinity.
we often do when we have two terms divided by one term,
Split them up.
right? It helps, usually. So how do they split then, Brendan?
One.
Is your name Brendan? 1 minus 1 over 2 to the n.
Alright, now when we take the limit of that, what comes out?
1 minus infinity.
That's not
Minus
infinity,
zero, I
but
think.
1 over infinity.
Oh, so 0. So
So-
1.
Very good. So it
So converges
converges.
at 1.
So not only, this is the amazing part, and it not only does this original series converge, it does add up to 1. So in infinity, 1/2 plus 1/4 plus 1/18 plus blah 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 is equal to 1. Which astounds me that you can take an infinite number and come up with an answer. But we can, so.
We're at 11 minutes.
Okay, this is a good stop. So, Jonathan, we'll pick you up
Oh, yeah, I
on the
forgot.
next part. See you in a sec.